Start. Good morning, everybody. Welcome to
Good
day
morning.
16 of Math 133. Um, so today we're going to cover the oh, today we're going to cover the Chapter 7 project. So last time on Thursday we had the midterm. So on the mid So on Thursday, we also assign lecture notes. So make sure you take a look at those lecture notes. Um, 7.1 had one of the videos missing, so I have a link in there for that now. Um, but if you've already turned that in, you're fine. So um, anyway, uh, and then after we work on the Chapter 7 project, if we have some time, maybe we'll take a look if anyone has any questions about the midterm at all. Um, if you're worried about how you did on the midterm, that's understandable. I mean, the you know, the midterm was long and it had a lot of questions on a lot of things that we covered. So, and it is a big portion of your grade. Can you pass the class if you failed the midterm? And the answer is yes. So the midterm is worth 30% of your grade. But even if you got a zero on that, you could still score 70%. Where does 70% put you? If we pull up the syllabus here, let's take a look at that. I didn't want to download it. So right here, a 70% is a 2.0, and a 2.0 is considered passing. So, um, it depends on what you're trying to do, right? So, uh, hopefully, I mean, we always want to do as best as we can. I want everybody to get a 4.0 if possible. Last semester, half of the people who finished the class did end up with a 4.0. So, um, you know, but if you feel that you didn't do particularly well on the midterm, we can take a look and, I'm happy to discuss your grade. Um, but also keep in mind that the best way to pass this class is to come to the video sessions, get things turned in on time, so that if you did bad on the midterm, all these other things, the projects, the participation, the notes and stuff, those will pull your grade up. So um anyway, uh
I got a question.
yeah, go ahead.
My sample midterm didn't get graded, which it knocked my grade all the way down because my
Oh,
midterm
no, the sample
didn't
midterm has
score a
not been
bunch of my.
graded yet. Yeah. No, the sample midterm has not been graded yet. The sample
Okay.
midterm is not the midterm. The sample midterm is one of the worksheets, and so that goes into the classwork, which is 20% of your grade. Uh, those worksheets are like the Chapter 7 review, the Chapter 6 review, the cumulative review worksheets. The sample midterm and the final exam um, sample, those are worksheets. The midterm exam, um, I've graded it for some people. I haven't graded it for everybody yet. I'll have all of them done by Thursday. So, um, but anyway, so if
I
you want
know
to talk
some
about
of
grades,
my stuff
go ahead.
not graded. Okay. Thank you.
Yeah. And the stuff that's not graded isn't bringing your grade down. It's just not factored in. So if I mark it as a zero, it will bring it down. But it's just not even factored in. So the grade that's showing there is approximately the grade that you'll see once everything's graded. So again, if you have more questions on that, we can look at it after we get done with our project for the day. So, um, but yeah, so now that we've finished the midterm, um, we're halfway through the class. And I'll just reiterate, keep in mind what your goal is for the class, right? Everybody's here because they want to be here. You're not here because, it's high school where you have to be there, right? So keep in mind that you want to pass this class, you want to put some effort in. And so if you did bad on the midterm, that should be assigned to just make sure that you're putting enough time in for the class. Okay. I know the class is a lot of work. Okay. So we mentioned that at the start. Um, so the good news is that the next couple, so now that the midterm's over, we're going to shift gears slightly. I feel like all the material up to the midterm, there's a lot and it comes at you very fast. Um, so I feel like after the midterm, the material is a little slower, so you don't have quite as much coming at you all the time that you need to get done. But it's a little more complicated. It's a little more uh, detailed in problems. So just be aware of that. So we don't have like any sessions where we're going to be covering two different things. Um, but yeah, so but the material afterward, I think, is takes a little more effort. So or a little more not effort, but it's maybe a little more confusing, and so you want to study it a little more. Okay. All right. So that all said, let's jump into our Chapter 7 project for the day. So here in Canvas, if you click on the Chapter 7 project, our home run distance is normal. There's going to be two links there. One of them is the link to a Google document. So you want to click on that. And then the other one is a link to the data set in StatCrunch. You'll want to click on that as well. And there's a video here that talks about how to do the assignment if you need. Um, but here is our Google document. So we're going to look at home runs in 2019. So we're going to start with doing file, make a copy. File, make a copy. Um, and you want to save that in a folder for the class. So you can save it either in My Drive, or you can save it if you have a different location that you want to save things, that's fine. So once you've done file, make a copy, you'll be able to edit this, right? And this link right here, this will take you to the same StatCrunch information that the link from Canvas did. Oh, well, I guess it's not going to let me right now because I'm not signed in. So make sure you sign in. So let me click on this. So here's StatCrunch, and here's all of the home runs from 2019. Okay, for Major League Baseball. So in the upper right, we'll hit sign in. Come on. Oh, goodness. It's making me do some extra work today. Sorry
That's
about that.
weird. Have you always
Yeah.
had two authentication on that, or is that
No, I've
new?
never, nope, I never had to do authentication on StatCrunch before. So
Yeah, that's
um,
weird.
usually I click the link, I click sign in or register, and the uh, yeah. Okay.
Of course.
Anyway, now I'm signed
Crazy.
in. So goodness. Okay. So hopefully everybody's able to get signed in to this data set, Home Runs 2019. Okay, great. And this, by the way, this is it's important to know whether we're looking at a sample or whether we're looking at a population, right? Because if it's a population, these are parameters. If it's a sample, these are statistics. And this is everything. This is all home runs from 2019. When we use the word all, that means it is a population. Okay, it's not just a random sample. So, okay, so back to, I guess I'm curious, like how long is this? Okay, so like there were 6,600 home runs in 2019. Um, okay, so let's take a look at our project for the day. So, question one, draw a frequency histogram of the home run distances and select a bins start of 250 and a width of 20. Okay. All right. So to do that, over here in StatCrunch, we're going to go to graph histogram. And then click on histogram. Graph
Sorry,
histogram.
your screen is really lagging. It's
It
like
is really lagging. Yep.
behind.
Yeah, and so I turned off my video. My internet's being really slow right now, so I apologize for that. So I'll try
Oh,
to move a little slow
no, that's okay. Just want
to make sure that my voice
to
connect
turn mine off.
catches up to my video. Um, okay, so yeah, here in StatCrunch, you'll go to graph and then histogram, um, and then you'll select distance. Okay, so there's a couple different columns here for uh, the home runs that were hit. But we want to start with distance because we're trying to figure out if the distance hit is looks like a normal curve or if it's skewed left or skewed right. Um, so the next thing we'll do is it told us to put in that the start at is 250 and the width is 20. Now, if we didn't know those numbers, we could have just hit compute and taken a look at our histogram and figured it out from there. But they told us in the project to change those. So right here where it says bins, we're going to start at 250, and that's 250 feet. These distances are measured in feet, and then the width of each bar, the width of each group will be 20 feet. Okay, and we'll hit compute. All right. That looks good. So now that I've got that, let's copy that s- uh, histogram graph over into our project. All right. Now, like I said, um, if we hadn't known how big to make our bars, we could have just gone graph, histogram, and if we'd just hit compute, and you don't need to do this part, um, it gives us this histogram instead, which still looks pretty good in my opinion. Um, but since the project told us to make the bars 20 feet wide, as opposed to, in this case, I guess the width is like 12 and a half feet, which 12 and a half feet's a little weird, right? It's a weird number to use. So we'll use 20 as our widths. Comment on the shape of the distribution. All right. So do you guys think that this is skewed left or skewed right? So taking a look at the shape, do you think this is skewed left or skewed right? What's your guess? So Andrew says skewed left. So that was a trick question because there's not two options. There's three options: skew left, skew right, or symmetric. And to me, this looks pretty symmetric. Um, this bar here is maybe a little taller than this one here, but I think that like if I drew a line down the middle, it would be pretty close to a mirror image, right? Um, Not only is it symmetric, but it's a special type of symmetric, where you've got this, mountain shape where it goes up and then it comes back down. So comment on the shape of the distribution. This distribution looks symmetric. Um, so not only does it look symmetric, it looks like a normal curve. A normal curve is that mountain shape, or like a bell shape, where it has a tail to the left, a tail to the right, and then it's got a peak in the middle. So the topic of today's project is, are home run distances normal? Um, and normal in statistics class means a specific type of shape. And to me, it looks like it is normal. But we're going to investigate a little more on some of these later questions to tell if it is normal or not. Okay. All right. So, question number 2, determine the population mean, the population standard deviation, and the population size for the home run distances during the 2019 season. Okay. So mean, standard deviation, and population size. Okay, so we know how to do that. So let's go back over to StatCrunch. Okay. And to do that, we go to Stat, Summary Stats, Columns. Are you guys seeing StatCrunch on my screen, or are you still seeing the Google Sheet at the moment?
StatCrunch.
Good. All right. Stat, Summary Stats, Columns. We'll click on that. And we want to look at the average distance, the mean distance. So we'll click on distance. So we need the population size, that's n. And then if I hold the control button down, I can click on the mean. And then I also need the standard deviation. However, this standard deviation is not the one I want. You need to be careful when you're looking at standard deviation because it's important to keep in track of whether you're looking at a population or a sample. It doesn't matter for any of the others like mean or median or anything like that. But for standard deviation, this one is for a sample. And if you scroll down to unadjusted standard deviation, that's for populations. So we need that. Okay. So I need mean, I need n, and I need the unadjusted standard deviation. And then I'll hit compute. And you'll notice that when you get enough numbers in your data set, the standard deviation and the unadjusted standard deviation are so close it really doesn't matter. For this particular case, we're looking at 6,000 home runs. And so my standard deviation is 26.261. My unadjusted standard deviation is 26.259. Those are so close that it's close enough you could use either one. But when you have a small sample size or a small population, you do need to pay attention to which one you're using. Okay. In this case, it is a population, so we should be using the unadjusted standard deviation. So I'll get rid of that. I actually want just the three. I want mean, n, and the unadjusted standard deviation. So there we go. And let's copy those into our Google Sheet, into our project. And if you copied the regular standard deviation in, I'm not going to take points off as long as I can still see the unadjusted one as well. So, or if you included like the median and other things, that's fine. All right. So now that we have that, question number 3. Draw the normal curve with the mean and standard deviation found in part 2 on the frequency histogram from part 1. Okay. Do this by selecting overlay distribution, choosing normal, and using the mean and standard deviation found in part 2. Also select the option to add value above the bar. Oh my God, this is a lot. What they're asking us to do here is redo the histogram, but now not just show the bars, but also show a curve for a normal distribution on that same graph. Okay, so that's what we're asked to do here. Paste the new histogram with the normal curve on the picture. Okay. All right. So let me show you how to do that. So let's go back over to StatCrunch and we're going to redo the histogram. So to redo the histogram, it's under graph and histogram. Select our distance. We still want the bins starting at 250 feet, and we still want the width to be 20 feet. But the next thing down is where it says display options, overlay distribution. So that's where we're going to put some additional things in. So click on the drop down next to display options, or it says overlay distribution. And there's a couple of different distributions. We're only going to talk about the normal distribution in this class. Actually, that's not true. We'll talk a little bit about the t-distribution. It's very similar to the normal distribution, but for today, we're just going to use the normal one. So can you guys see on my screen the drop down where I select normal? You see that?
Yeah.
All right. Once I select normal, it's going to ask, okay, what mean and standard deviation do you want to use? And we need to put in the mean and the standard deviation that we found a second ago. So the mean was 400.22. So let's put that in there. And the standard deviation we found was the unadjusted one, which is 26.26. Okay. And then we also want to check this box, which says value above the bar. And that'll just put the number at the top of the bar. We could have actually done that without the overlay, but that's fine. So this is everything I want. I want the distance, start at 250, width at 20, overlay a normal distribution where I have my mean, I have my standard deviation, and I want the value above the bar. So that all looks good. Let's hit compute. And we get this. Okay. And we'll copy this into our project. So you can see we've still got the histogram bars. Now we've got the frequencies of each bar at the top of each one. So we have the numbers. So how many home runs were on this bar, how many were in this bar. And then we've got this red curve, which is a normal distribution curve on top of that. So paste the picture here for number 3. All right. Do you think a normal model would describe the variable distance? What do you guys think? Yes or no? Andrew says yes. Yeah, I agree. So normal curve is the same shape as the histogram. Now, if so, we're not required to do this for a different column, but if we had used a different column that was not the same shape, using your mean and standard deviation on something that's skewed, the red curve would still be there, but the bars would either be to the left or right, depending on whether it's skewed left or skewed right. And they wouldn't fit nicely under those red bars or under that red curve if it was skewed. And that's because, mean and standard deviation, they're not good measures when we're talking about skewed data. Mean and standard deviation are really best when we're talking about symmetric data, which is what we have here. So, okay. Question 4. Find the relative frequency with which a home run distance between 350 and 389.9 feet is observed. And use the frequency histogram, show your work, and give 4 decimal places. Okay. Find the relative frequency. Relative frequency is a decimal. It's a proportion. So you'll remember when we were talking about frequencies and relative frequencies, frequency is a whole number. Relative frequency is a decimal. And the way that you calculate your relative frequency is you take your frequencies and you divide by the total. Okay. So that means that we need to find how many home runs were between 350 feet and 390 feet, 389.9, but close enough. How many home runs were hit in that range, and then divide that by the total. Okay. So let's go look at our histogram here. So 350 is right here. This bar right here says there were 699 home runs hit that were between 350 feet and 370. Well, that's not quite what we want. We want 350 to 389, or 389.9, right? So that's 699. The next bar over says there's 1,415 home runs that were between 370 feet and 390 feet. Now remember, when we're looking at these classes, at these groups, these bins, uh, the high number, the higher limit, is not actually 390. It's 389.9. Okay. Um, so that's actually what we want, is we want these two bars. This one's 350 to 370. This one's 370 to 390. So if I add these two bars together, that'll give me what I'm looking for, which is 350 up to 390. Okay. So let me do, so 699 and 1415. So we have 699 plus 1415. I don't know why it's in red. It's fine. So we'll add those together, and then we need to divide by the total. What was our total again? Somebody give me the total. What was the total number of home runs in 2019? There's a couple places you could find it. What's the total number of home runs in this data set? I mean, you could add all these numbers up, 4 plus 9 plus 146. That's the long way to do it. You don't need to do that. I mean, you can. I'll still give you the answer. What's the total? So when we did our summary statistics, we got three numbers. We got our mean, we got our unadjusted standard deviation, and we also got N, and N is our total. It's how many home runs were hit. So 6,677. Okay. All right. Can someone calculate that out for me? We should get 0 point something. Thank you, Jacob. 0.317. Can you give me one more decimal? I want 4 decimal places for this. 3166. Excellent. Thank you. All right. So that means that 31.6% of the home runs were between 350 and 390 feet. Okay. Next thing we're going to do is we're going to do the same, we're going to get the same answer or something close to it. But now instead, we're going to use the normal curve to find the area under the normal curve between 350 and 390. So we'll go to Stat, Calculators, Normal. Okay. So Stat, Calculators, Normal. Okay. Oh, let's close that. So click on Between, and we're going to put in a couple of different numbers here. First of all, our mean was 400.22. Standard deviation was 26.26. We want to look at 350 to 390. So put those 4 numbers in. 400 for our mean, 26 for our standard deviation, 350 to 390. And then you'll hit compute, and that'll give you a proportion for what percent of the normal curve is between those 2 numbers. Okay. So I get 0.3207. 3207. Oh, and we'll just copy and paste the chart. Okay, so we can do that. So instead of just putting the number in, we'll copy the chart here. Okay. Compare and contrast the values found for 4A and 4B. So what we're trying to do is we're trying to show that the home run distances are very close to a normal distribution. So this is saying that 350 to 390 was 31% of the home runs. Down here, it's saying that if you use a normal curve with this mean and standard deviation, then 350 to 390 is 32%. So those values are very close. Okay. Really, what it comes down to is if you know if you have a normal distribution, it should look like this shape where it starts low and then goes up and then it comes back down. So we can already see that home run distances are very close to being normal. But now this is even more evidence that they are. Okay. Although I guess I'm a little surprised that home run distances follow a normal distribution because there's a wall, right? There's a home run wall, so there's like a cutoff, right? So if the home run wall is 300 feet out, or not, I guess not 300, I guess most of them are like 400 feet out, depending on which part of the field you hit to. But I would think that there might be like a cutoff where like you don't have a tail to the left, right? Because like what's the smallest one? The smallest one was looks like there's 4 home runs that were 300 feet or somewhere in the 300-foot range. So maybe those were in Boston because there is a part of the wall that's in Boston that's short. So the big green monster, they call it. Anyway, let's move on to number five. Number five is really very similar to number four. Um, find the relative frequency again, with which a home run distance exceeds 430. And then we'll do the same thing looking at the normal curve and find the area under the curve to the right of 430 feet, and then compare and contrast those. So probably those are going to be very close again. So question number five is very similar. So find the relative frequency for a distance that's over 430. So let's go look at our histogram. So 430 is this one. This one says there were 669 home runs that were 430 to 450, but we want all the home runs that were over 430. So we want those ones, but we also want these 160 and these 29 here, right? These 29 were from 470 to 490. Okay. So I want all three of those. So 669. 669 plus 160 plus 29. And then our total is still 667. So thank you, Andrew. So Andrew added up the numerator for us. So 669 plus 160 plus 29 is 858. And then we need to divide that by the total. So can you give that to me as a decimal? Should be 0.1 something. I want 4 decimals. Zero 0.1285. Thank you. So 12% of home runs were more than 430 feet. So those are big hits over 430 feet. Those are huge. Okay. Next, we're going to use the normal model to find the area under the normal curve to the right of 430. Use stat calculator's normal and copy and paste the chart here. So back over here with our chart, switch to standard. And our mean is still 400.22. Standard deviation is still the same. But now we want greater than 430. Okay. And the reason I know it's not between is because I'm only looking at greater than or less than for a single number, just 430. So, and this says that 12.8% are bigger than 430. So we'll copy that. All right. So this one was 12.85 using our histogram math. This one is 12.84 using the normal math. So those are really close. Compare and contrast those. These two values are extremely close. So yeah. All right. Those are like off by less than 0.1%. So, all right. Question number 6. Which type of model? Histogram, or normal curve do you think is more appropriate for analyzing home runs in the year 2019? Okay. Which type of model is more appropriate for analyzing home runs? So if uh, if this wasn't a normal shape, then the answer would definitely be a histogram. So if we had any skewness where it was like, okay, it's a little skewed to the left or it's a little skewed to the right, I would want to use the histogram, okay, because then you can see that. Um, but in this case, it seems that the distances are extremely close to the normal curve. So I would say the answer is a normal curve here. What do you think, Elaine?
I think the normal curve is good, but I also think since it's continuous data, it should be normal.
Hmm. Yeah, so we could say since it is continuous. Well, you can have continuous data that's skewed. So I'm going to say that it's better. Normal curve is better since uh, so one of the reasons why we like the normal curve is because we can do things like this with the normal calculator, which is going to be a lot more a lot quicker than adding all of these bars together. Like if I had asked you, what percent of the values are less than 450? Well, I'd have to add this bar plus this bar plus this bar. I'd have to add all of these bars together. Versus here, I would just say, oh, less than 450? Sure. Switch this to less than, change this to 450, and hit compute, and I have my answer very quickly. So, um, yeah. But there's not really a necessarily right or wrong answer for this question for 6A. Um, but in this case, I think the normal curve is good. Okay, which model do you think is more appropriate for inferring about home runs in years other than 2019? So we don't actually have data on the other years, but do you think that 2019 was special and was normal shaped, and other years would not be normal shaped? What do you guys think? Or do you think other years would also be normal shaped? What do you think? Yeah, I would agree, Jenica. Other years would also likely be normal shape. Yeah, I mean, there wasn't anything necessarily special about the 2019 baseball season. And they didn't like move the fences or anything from one year to the next. So I would think that other years are also going to follow a similar pattern. Okay. Um, all right, cool. So now that we've got that, uh, so in the upper right, you're going to click on share. Make sure you change the access from restricted to anyone with the link. Well, it's not letting me. Come on. Yeah, this whole weekend internet's been slow because of the Amazon crash, all the AWS stuff being down. So Canvas was down, so that was terrible. Um,
Yeah.
we'll copy our link and then scroll here down to the bottom and we'll submit our URL here. All right, got our confetti. So, by the way, if you did try to turn in any notes, the notes are due today. Uh, the lecture notes. If you've already tried to turn them in and weren't able to because Canvas was down, you should be able to turn them in now. Okay. All right. That's it for our project for the day. So I think what we'll do is we'll stop the recording and we'll answer any questions anybody might have about the midterm. I think that starting on Thursday, we might actually pull up the midterm and go over a few questions. But for now, if you don't have any questions, feel free to drop off. Otherwise, yeah, I'll stick around and I'll answer any questions you might have.